Heyo, it's Tobin. This will be a quick one on some web performance stuff. By quick, I mean between 5 and 40 minutes or several hours. I don't know. I don't really think about these things before I do them. They don't come from me so much as they go through me. Like a burrito. So, I made a blog post not too long ago. Somewhere. About web performance and how average pages are well above 2 megabytes now. And that just kills performance, particularly on mobile. I talk about some things I was doing to combat that with GeoPortal, which is one of our more popular sites. It gets around 25,000 users a month. Not that it matters. It could get like 2 users and I'd still get paid the same, but it does good business. And by doing some different things, I was able to get it down to 567 kilobytes. Ooh, went up to 568 because I updated some dependencies like the latest GLJS. So it went up a kilobyte. Urgh! But it was around 568 kilobytes. But I set a goal of 500 or less, so I kept chopping. One of the things I chopped out was Axios. Axios is like a request helper library because your standard, XXJAR request is somewhat ugly. But instead I just went with fetch. Fetch is the new standard way to do that. It's supported on all the browsers except for IE, but there's a tiny little fetch polyfill library that works great. And then you need a promise polyfill library as well because fetch returns a promise. But I already needed one of those for Axios anyway. So I shaved a little bit of space, but the big space shaving I got was from fonts. And I was loading a couple different things. I was loading Roboto for the main application, and I was loading Material Design Lite icon set for all these fancy pants icons. And that was taking a lot, as it turns out. It was the Material Design Lite icon set by itself is like 42 kilobytes. So I cruised over to Fontelle, which is a great tool, and I picked just the icons I wanted. End up with like 18 icons or so. The neat thing about Fontelle is you can import SVG icon sets, and Material Design Lite has an SVG icon file in their GitHub repo. So I was able to keep the icons I liked from that and get icon glyphs from a bunch of other fonts too. They have Mackie on here too. It's really nice site. So that got my icon font file down from 42 kilobytes to about 5, like 5.6 or something. That was super awesome. And I stopped loading Roboto. Instead, I went with system fonts. And system fonts, well, you can't read that. Let's see, how do I make this? There we go. System font is kind of the cool new way to do fonts. And it basically uses some not really standard things here at the front. And then fonts that are like the standard font on your various platforms. So this just uses whatever the system is using or tries to. And that way you're not downloading any kind of font. And it's the font that folks are used to seeing anyway. So, yay. That got me from, let's see here. Can I make this bigger? Oh, yeah, a little bit. That got me from 568 kilobytes to 494 kilobytes. Less than 500 kilobytes for a whole GIS site with all kinds of stuff and a map and everything. Yes, victory. But mobile performance still kind of sucked. And we can simulate some throttling. Like, let's just go regular 3G here and try this out. It's going to take around 6 seconds. And, oh, 6.03. You can tell I've done this before. But you have to bear in mind when you're using this throttling simulator is that the only thing you're simulating is the network speed. You're not simulating the crappy CPU on somebody's phone. And what I found in real life testing with my Nexus 5 Plastic Wonder was that it was really more like 12 seconds. And the big hiccup here wasn't just loading the data, it wasn't just the network speed, it was making that map. WebGL and making a WebGL map and rendering all that stuff. That's a pretty good bit of work for your CPU. In your phone CPU, or whichever, your phone has like different CPUs. You'll go, hey, it's like a 12 core, so it must be like better than my server. But the CPUs are all different. They have like really low power CPUs and higher power CPUs, and it's just like a dog's breakfast in that phone. So in real life terms, the performance was more like 12 seconds, which is a lot over a 3G network. So I did something else. And we'll get this down to single column mode if I can grab this corner and load this again. Now, notice we're finishing before on regular mode with no throttling in anywhere from 1.2 to 1.5 seconds. Now we finished in about half that, 750 milliseconds, and we only transferred 309 kilobytes instead of 494 kilobytes. And the reason is this. What I do now for screen sizes that are probably mobile, like a phone, basically when the app goes into single column mode, when the page is loaded, is I don't load the map. In this particular site, the map is somewhat ancillary. It's neat. I mean, it gives you some useful information, but you can go find your school assignments and trash pickup days and whether you're in a floodplain and where you go vote. None of that has to have a map. It can just tell you. And by doing that, we'll go back to throttling. Oh, I'm going to have to make this smaller so we can see throttling. Go back to regular 3G. And instead of 6 seconds, it's going to go down to maybe 4.04 seconds. You can tell I've done this before. But that's just testing network speed. In terms of actual performance, it went from around 10 to 12 seconds to about 6 to 7 seconds. It cut the mobile performance in half just by not drawing that map by default. Instead, you get a button, and if you want to, you can optionally draw the map. It's drawing over 3G here, so it was a little bit slow. Simulated 3G. So that's how that works. So if you were on a page that was 2 column, it would automatically draw the map for you. If you're on a single column, which you're more likely to run to on a mobile device, it makes the map optional. The other thing it does is if you are in single column mode, so when it loads, you get that button. If you move the screen out to 2 column mode, it'll automatically load the map. So it figures you were probably just dorking around and your screen was too small and you made it desktop size and it just loads the map for you. So that's how we took the mobile performance and cut it in half, and even got down to like 309 kilobytes instead of 494. Now, what does that look like in terms of code? I have to warn you, it's not pretty, which means I'm thinking about the problem wrong. Whenever you get ugly JavaScript code, it usually means you're thinking about the problem in an incorrect way. So it ain't pretty yet. This is what we do. We have that button sitting in just underneath the map, and we do a little set default display to none, and if the media max width is 840 pixels, then we display that button. Now in the app, we're going to set a variable and just set it to null, and that's going to hold our view component when it loads, so we can tell if we've loaded the map before, so we don't try to do it twice. Set up some view data, and here is where we will handle the toggle map click. We get that component and we add a click, and if GL is supported, because the application will still work fine, if WebGL isn't supported, it just doesn't load the map, which is kind of neat. Now if GL is supported, we'll initialize the map, and that's that click of that button. Now if GL is not supported, we'll just get rid of that button, and that's what that does. So that just handles the button to show the map. Now when the page is loaded, it will check to see if GL is supported, and if the map is, or if the body is not in single column mode, so it's greater than 840 pixels. If it does it, those are both true, it initializes the map. Then we set an event listener for the window for a resize. And when the resize event fires, it checks if GL is supported, and if the document width is not in single column mode, and it makes sure that the map hasn't already been loaded. If all that's true, it initializes the map. And that's how it works. If you're in single column mode when you load, but you make the window larger, it'll automatically hit it here and load the map for you. Finally, here's how we initialize the map. We set our variable to that view component. We get rid of the toggle button if it is still there. And then we remove the event listener for the window resize. And that's not something I usually do, but it's probably something I should do more of. Clean up events that I no longer need, particularly window resize. I remember that used to drive Internet Explorer nuts. You'd move your window around in a way that no regular user does. You know, you're just a web developer being a jackass. You'll just grab the window, move it back and forth, and IE would just flip out because it fired this event every single time. So we're just removing that event. And that's all the code to get the map to be optional. And the other thing that makes it optional is because I'm using Vue.js, and the map and all of the other components are totally isolated from one another. So the map can just not be there and everything else keeps working fine. I could take out the parks and the voting. Everything would be fine. It would just keep working. That's one of the nice things about really clean component development, and Vue.js just really encourages that. Vue.js is awesome. Anyway, that's how I got the page load down, the page size less than 500 kilobytes, and for mobile just over 300 kilobytes, and how I cut the mobile performance time for the app in half just by making the map load optional. And that's probably, I mean, there is actually still some stuff I can tune on this app. I still have some CSS classes left over from material design that just aren't being used. I can weed out too. But now I'm getting down to like microseconds, and life's pretty short, so I might stop there. This code for the whole site is all up on GitHub. I'll leave a link in the show notes, and that's how I got the performance of on mobile in half, and now I got the page size down by a whole bunch. Well, hope you found that helpful. I will catch you later. Bye-bye.